This is a test of the GASPACS FlatSat system with an AeroBoom deployment. So we're going to allow the system to power on. Currently the kill switch is pressed down and there's no power on the whole system.
You want to hook up the other microphone?
No, we'll leave it off. So this system is fully detached from any external power or connections. So we'll let it power on. You'll be able to see a light in the EPS start blinking. And then the Pi will start blinking. And now once the Pi boots up, it's going to be in the pre-boom deploy mode, where it will be looking for the correct amount of darkness and then sunlight before it triggers the boom deployment. One potential problem with this setup is this very long length of wires that we have between the FlatSat system and the boombox, which is going to increase the resistance and potentially cause that wire to not get hot enough to deploy. So we will see if that poses a problem. If so, we can move the system closer to the edge of this table, but this was the easiest for right now. Give it another 15 or 20 seconds to make sure it fully boots up. Alright, and we will now simulate darkness by covering the sun sensor. Logan's going to point the camera at himself so we can try to take a picture of him. So we'll cover this for about 15 seconds or so. Alright, now we're back in sunlight. So if all goes well, in about 10 seconds or so, this boom should be deployed. Hey, there we go. Beautiful deployment. Now we'll get us a nice picture of Logan. No, because it's got to go through. It triggers the whole thing several times.
Yeah.
It triggers each system. So that was a beautiful deployment. Came straight out. The end plate is a little bent over, but that's because we have gravity here, and it's confined in this chamber. But in space, that will not be an issue. See in there, we're sticking straight out of this bottom plate. The whole thing looks to be in great condition. Yeah, Logan, we're gonna have to wait another, because I don't remember how long it waits between each burn. Shouldn't be no more than another hour or so. Alright, I'm going to start working over here on getting the picture transmitted over.
Still keep going.
I mean, we don't want to take a picture of the table.
Yeah.
Well, I mean, the table's just pretty boring. Ouch.
I see how it is.
Okay, that's probably good, Logan. All right, so now we're connected to the Raspberry Pi that's sitting up in the corner over there with a transceiver on it. And what we will do is we will send a command over the radio, which will schedule a time to transmit down this picture that we just took. So we're going to create a new packet. It's a window. It will start in 30 seconds, and the duration will be 45 seconds. We're going to get a low quality picture, which is data type 4, and it's picture number 2. Sending data. And so now this system should send it over. Now we'll go over here and prepare to receive it. And if all goes well, in a few seconds we should see data start pop up on this screen. Let's try to send it again, requesting the picture. One thing is that antenna got turned and pointed straight over here, and I don't know if that has any difference. We moved the location of the other transceiver.
Did it not get it?
No, it didn't. It
Okay.
didn't get it.
Yeah, because theoretically, if they're pointing right at each other, you have 0 gain.
So just turn to the side. There you go.
Can you also check that it's on?
It's on. I'm connected to the.
Oh, right.
I'm about to send a command. Do you want to see if it blinks?
Okay.
All right. Should have just sent.
Yep.
Okay. I wasn't looking at this one to see if it received it. Oh, there we go. So it must have been that antenna was pointed the wrong way.
Yeah.
So believe it or not, all of this code right here is a picture. All split up into little packets encoded in hex.
Yeah. Negative 45 dBi gain if they're pointed at each other.
That's not very good.
Not at all.
So note to self, don't point them straight at each other.
Yeah.
And test your setup before you run the full tests. But it worked. We've received the picture data. So next what we will do is decode it from hex into a JPEG. All right. We're going to call this boom deploy pic.jpg. All right, we read 207 packets in. Now we'll open up FileZilla, our old friend.
Inshallah.
I'm going to put it straight on our desktop. Integration, CubeWorks, ground station. Drag it over to our desktop. Desktop. Boom deploy pic. Hey, there we go. Got a beautiful picture of Logan. So if that was in the boom box, we would have gotten a nice picture of the deployed boom. But for right now, we don't want to put this whole setup into the vacuum chamber just yet, because we need to take some ESD precautions and make sure all of the systems work. But this is a great proof of concept. We successfully had our flight logic, deploy our boom, take a picture, receive a transmission window, and then transmit the picture back down, which we decoded. So if this all happened in space, we would be looking at a picture of our deployed boom right now.